As you can probably tell by now, we are diving deeper and deeper into React. And in this module, we're going to have a look at another core concept which you will use in a lot of React apps you're going to build. And that will be custom hooks and how you can build your own custom hooks. Now, up to this point in this course, we already worked a lot with hooks, with the built-in React hooks React offers to us, like use state, use reducer, use effect, use context, and so on. So all these special React functions that start with use. You might remember that when I talked about the rules of hooks, I mentioned that you can only use React hooks in React component functions and in custom hooks. And I told you that those would be covered later. Well, now is later. Now we're going to explore how you can build your own hooks, why you might want to do that, how exactly you do that, of course, and we're going to do that at a concrete example or multiple examples. And we're also going to learn about the rules and practices and best practices that apply when you build your own custom hooks. So, what are custom hooks? And we need to clarify what they are before I can dive into the why. So, what are custom hooks? Custom hooks are in the end just regular functions, just as the built-in hooks like use state are in the end just functions, but they are functions which can contain stateful logic. You can build custom hooks, these custom hook functions, to outsource stateful logic into reusable functions. Unlike regular functions, custom hooks can use other React hooks, including other custom hooks, and they can therefore also leverage React state managed with use state or use reducer. They can access use effect and so on. With custom hooks, you can outsource logic, which you might be using in different components, into a custom hook, which you can then call from all these various components. So it is simply a mechanism of reusing logic, just as regular functions are, with the special thing that in these custom hook functions, you can use React hooks and other hooks. And that might, of course, still be a bit abstract. So therefore, let me give you a concrete example which shows you why you might want to explore custom hooks and how you then build a custom hook step by step and how you use it. Here is an example application. Of course, you find it attached. And as you see, this application has, in the end, just two counters. One counter counting upwards, one counter counting backwards. And of course, that's not a fancy application. We're going to see another example later in this module, but this application allows me to explore custom hooks together with you, show you why we might want to build custom hooks and how we build custom hooks. So here's the code for this application, which again you find attached. And in here, we in the end just got three components: the backward counter and the forward counter, the card component, which is just a wrapper component providing some styling, and in app.js, I'm using the forward and the backward counter components, and these components do just what their name implies. The forward counter uses use state and use effect to manage a state, and to create an interval which simply starts counting up and which then sets a new counter state every second, every 1000 milliseconds. And in the backward counter, I'm doing the exact same thing, but here I'm subtracting from the counter. But other than that, it's the same logic. So therefore, it is fair to say that these two components are fairly similar. Now, of course, we might be able to create one component instead and then use props to configure it differently, but it would also be realistic that in real applications, you have different components which, to a certain extent, might do related tasks. And it is fair to say that we therefore definitely have some code duplication in the forward and the backward counter. If we leave that small detail of subtracting or adding to the counter aside, it's exactly the same code in the end. And whenever you have code duplication in programming, you typically want to take that code and refactor it and create a function which holds the shared code. And that's exactly what we're going to do with custom hooks. Because the problem we face here is that the code which we want to reuse uses React hooks like useState and useEffect, and it updates the state by calling the state updating function. And as you learned with the rules of hooks, you are not allowed to use these React hooks in any random function. You must only use them in React component functions or custom hooks. So if we want to outsource that logic into a separate function, we need to build such a custom hook. And that's exactly what we're going to do here. So how do we build a custom hook then? Well, typically, just as with components, we store every hook in a standalone file. So I will start by creating a new hooks folder side by side to the components folder. And in there, I will add the use-counter.js file. Now, the file name is totally up to you. You don't have to name it use-counter. I do name it like this though, because there is a clear rule which we have to follow when it comes to the function name inside of that file. Because we are going to create a function here, either as a const which stores a function or with the function keyword. I'll go for the const approach, but both would work. And that function which you do create has to start with use in its name. That is a must do. That is a hard rule which you have to follow. It will be a normal function in the end, but the use at the beginning signals to React that it will be a custom hook, and it gives React the guarantee that you will use that function by respecting these rules of hooks, so that you will use this custom hook function just as you use the built-in hooks. And that is a guarantee React needs, because otherwise, if you start using React hooks in your custom hook, and you would use your custom hook in a forbidden place, you would implicitly also use the built-in hooks in a wrong place. And that's why we start with use here, because React can look out for that. And actually, this project setup will give you a warning if you have a function starting with use and you then start violating some of these rules of hooks. That's why this is a must do. Start with use in the function name. And thereafter, you can name it however you want. I will name it use-counter and then store a regular function in it. And because of that function name, I also named the file like this. But again, for the file name, there is no specific rule. You could name it however you want. Now, of course, ultimately, the goal is to use this function in another file. So therefore, I will export this function here. And then inside of this function, we can start adding that logic which we want to reuse. And in our case, if we start with the forward counter, in the end, we can just copy that code here. From the forward counter, that code where we use useState and useEffect, not the code where we return JSX, just the other code. Copy that and add it inside of that useCounter function. Now, since we are using useState and useEffect now, we need to import these things from React, because you always need to import what you use. So here we import useState and useEffect, like this. Now we got this logic in this custom hook function. But of course, in the end, we still want to utilize it in our forward counter and later also in the backward counter. How can we do that? Well, you are going to use a custom hook just as you use the built-in hooks. You are just calling it like a function because it is just a function. So therefore, we want to import useCounter here in the forward counter component. Import useCounter from going up one level, diving into the hooks folder, useCounter. And in the forward counter, we can then just call useCounter. Now that alone will not do everything we need to do, but it is a start. Now we are calling this custom hook function. So when this gets called, obviously all that code will execute. So that state will be registered and that effect will be fired. Now, if you call a custom hook in one of your components and that component, for example, registers a state or an effect as we do it here, then this state and effect will be tied to the component in which you use your custom hook. So if I call useCounter in the forward counter component, the state created here in useCounter will be tied to this forward counter. If we use a custom hook in multiple components, every component will receive its own state. So just because we use a custom hook does not mean that we share state or effects across components. Instead, for every component, the custom hook is executed again, and every component instance then receives its own state. So it's just the logic which is shared, not the concrete state. So therefore, in this case, since I call useCounter in the forward counter, this state is set up for the forward counter, and this effect is set up and fired for the forward counter component. But of course now, inside of the forward counter, I need access to the counter state, which is managed by the custom hook, because I want to output it here. And how can we do that? How can we make that happen? Well, just as we do it with the built-in hooks. For useState, this built-in React hook, this also does something behind the scenes. And it also creates and manages state, and then it does one important thing. It returns an array, which we are destructuring here. Custom hooks are just functions, and therefore they can return things. So here in the case of useCounter, to make that counter state available in the components that do use this custom hook, we can simply return it. We can simply return counter. You can return whatever you want to return in your custom hooks. That could be an array, or an object, or a number, or in this case, implicitly a number, because counter will hold a number. So now I'm returning this counter state here. So this state, which is managed or which is set up by that custom hook, I'm returning it here. And therefore, in the forward counter component, where I call useCounter, I can, of course, use that returned value. And here I can set up my counter constant, set it equal to calling useCounter. Since useCounter returns the counter, I can store it in a constant of this component. And now we can get rid of all that old code in here and slim down this component like this, get rid of the imports because we're not directly using useState or useEffect in this file anymore. And now we got this slim component. And if we now save that, you will see that if I reload here, this counter, this forward counter, still works as before, but now with a custom hook. And that is how we build custom hooks and why we do it. And when it comes to the how, the most important thing really is just the naming. You have to start with use. And then you can use stateful logic in there, you can use other React hooks in there, and that allows you to share this logic across components. And speaking of that, let's now make sure that we can use this custom hook also in the backward counter component. So In the backward counter component, we got the same logic as in the forward counter, but we are deducting here instead of adding. Nonetheless, we can use our custom hook here. We just need to do something which we often do with functions that we write. We make them reusable and configurable, you could say, by accepting arguments, parameters. Just as our components receive props, and just as any function in JavaScript or programming in general can accept parameters, custom hooks, since they are just functions, can also accept parameters. And for example, the built-in useState hook also accepts a parameter where we set the initial state. The built-in useEffect hook even accepts two parameters where we have our effect function as a first argument and our dependencies array as a second argument. So that is something which we do already implicitly and which we can now also do for our custom hook. So which parameter could we accept here? Well, in the end, we want some indicator that controls how the counter should be incremented. We could accept this entire updating function here to make this really flexible. So here we could have our counter update function as a parameter, and then in our custom hook, just execute counter update function like this, and expect that the argument we get here is then a function that can be executed, which gets the previous counter and accepts the new counter. Or we don't make our custom hook that flexible, but instead we accept some flag, some Boolean flag here, which controls whether that should be a plus or a minus. So we could, for example, accept a forwards parameter, the name is up to you, which is true if we want to add and false if we want to subtract. And we could even set a default value so that this parameter is optional. And then here inside of setInterval, we just check if forwards, if that is true, then we update setCounter like this. Else, if it's not true, we update setCounter by, well, basically just having the opposite logic of deducting. And that's the approach I will use here, but you could also accept the entire function. Either way, we now have a new dependency here in this effect in our custom hook, because the parameter which I'm using in here, that is a dependency. It's not defined inside of the effect function. It's not defined outside of our custom hook. Instead, it is a value that we get as a parameter here, and we have to add it as a dependency therefore. So we should add forwards as a dependency, so that this effect will rerun whenever this dependency changes. Of course, depending on the code we write in our components, where we use the custom hook later, this might never change. It might always be true or false and not change for one and the same component. But that's fine. If it never changes, this simply never runs again. We still have to add it as a dependency to follow all best practices and to ensure that if we would have a component where useCounter is used with different values for the argument, this effect would rerun if the argument changes. And that makes a lot of sense, by the way, because if we had a component where the counter can switch between forwards and backwards, we of course would want to restart the counter with the new logic if the value changed. But that's just some side theory here. For the moment, it doesn't matter too much. We can just go to the backward counter and import useCounter there as well, by going to the hooks folder and importing it. And then in there, in the backward counter, we call useCounter and we pass false as our argument here for our forwards parameter, because here we don't want to go forwards, we want to go backwards. We didn't need an argument in the forward counter. There we can call it like this because we got a default value in the custom hook. But if we want a different value than that default value, we have to pass it. Well, and with that, we can again extract our counter by using that return value. and then get rid of all that other logic in the backward counter component like this. And if we now save that and we reload our application, we still have both counters working, but now with our custom hook. And of course, this was a made up example here, and of course, besides the example on its own not being too realistic, you could definitely also find more ways of reusing logic here and working with one component instead of two counter components. But this was just there to introduce you to custom hooks. Now let's move on to a more realistic scenario where custom hooks can really shine. So here's a more realistic project. Attached you find this project where, after you downloaded it, you need to add in your Firebase links, and therefore, to understand what's going on here, you should make sure that you did not skip the HTTP course section, the section where I talk about connecting React apps to a backend. There I show how to set up Firebase as a dummy backend, and I show how sending HTTP requests works, which is of course something you need a lot in any kind of application you're building basically. So in this application here, we are sending requests, and if you want to follow along on your system, you should therefore make sure that you have a Firebase account. You can get started for free, as shown in this HTTP course section, and that there you are using the real-time database, and you got your rules configured like this. Set both read and write to true, or use the default test mode configuration, and then use this URL, which you find under data, and use that URL here instead of my URL. Keep the /tasks.json part though, you will need that. So that's what you should do to follow along. But what's this application doing? Once you updated the code and you installed all dependencies with npm install and you started the project with npm start, this is what you'll see on the screen. It's a simple tasks application, a very simple one actually, where initially the tasks are loaded. And if we have no tasks, we of course have to add some tasks first. For example, learn all about hooks. And you simply click add task, and now this is sent to Firebase. It's also displayed down there. And if you reload the application, it's loaded and displayed. And it's stored here on Firebase. Now I am only using what you learned in the HTTP course section, and this all works by sending a HTTP request with the fetch API, by handling errors and a loading state, by transforming the data when it arrives, and by then displaying the data. And we got various involved components, but most importantly, we got the app.js component where we are fetching tasks with this fetch task function, which is either executed because the component loaded due to use effect, or because inside of this tasks component a button was clicked, a button which is shown if we had an error, which allows us to try again. So that's when this fetch task function is triggered in the app component. And besides that, in the new task component, we got the enter task handler function where we also send a request, but here we are sending a post request with some data attached to store task data on Firebase. And this function is triggered whenever this task form is submitted in the end, which happens when this button is clicked and we verified the entered value. Now, feel free to pause the video and dig a bit deeper into the code, but that is what's going on here. And if you followed along in the HTTP course section, which you should have, then this is all basically just something you already saw. Now, I did create this basic yet more realistic example because here we also got another chance of adding at least one custom hook. And do you see where we could utilize a custom hook? Well, we got two similar kind of operations in two different parts of this application. And that would be here in the new task component when we send a request to store data, and in the app component when we send a request to get data. Now, regarding the details, the code is different. When we get the tasks, we configure the request like this. We send a GET request without a body and without headers, and we have some transformation logic which we apply to the response. Whereas in the new task case, we send a POST request and we do add data, and we have a different transformation logic for the response. But even though these details are different, there are a lot of parts where the code is pretty much the same. For example, in both components, we are managing a loading and an error state, and we are setting the loading and error states in the same way. We are also having the same error handling logic here, and so on. So there are parts which are quite similar. And because that's the case, because we have some code duplication, some code reusage here, because of that, we might want to consider outsourcing this logic into a separate function. But since the logic, or at least parts of the logic, which is being reused, contains the usage of other React hooks and the usage of state, since that's the case, a regular function won't do the trick, because there we're not allowed to use React hooks. That's why here we have a great opportunity for building a custom hook where we outsource the HTTP logic and then still in the end can reuse that stateful logic for the loading and error state. And that's therefore what we're going to do now. We're now going to apply our custom hook knowledge to build another custom hook, but this time a custom hook which in the end encapsulates this HTTP logic. Definitely feel free to try this on your own first. It'll definitely be challenging, and there also will not just be one single way of doing this. Nonetheless, try it on your own first. In the next lecture, we're going to implement it together. So, were you successful? Let's try this together now. And for this, in the source folder, next to the components folder, I will add a hooks folder. This is just a convention, not something you have to do. You can name it differently, but I will follow this common convention. And then add a new file in there, which I'll name use.http.js. Again, this name is also up to you, but since I will create a HTTP-related custom hook in there, I think this is a fitting name. Now the hook function itself, I will call that use.http, following this must-use pattern where your custom hook functions must start with the word use. And I will export this custom hook here because, of course, I want to be able to use it in other files. Now, regarding the content of this function, as I said, there will be more than one solution, and definitely feel free to share your alternatives in the Q&A section if you want to. I'm just showing you one possible approach which I came up with. And for that, let's have a look at the general logic we want to outsource. In the end, it is the loading and the error state, but then also the entire code where we send the request, where we evaluate the response. All of that should be outsourced. Also this error handling here, where we then set the error state, that all should be part of the custom hook. And therefore, I think it is reasonable to go to the app component and grab this entire fetch tasks function and grab these states here, and in the end copy that into use HTTP into this custom hook function. Now here we can get rid of this tasks state here because that's a bit too specific. That's specific to the app component. That's not something I would want to put in the use HTTP custom hook itself, because this hook should not just be usable with tasks, but with any kind of data. but I will definitely keep the loading and error state in there. Now, of course, to use state in this file, as always, we should import use state from React. And I will rename this function here from fetch tasks to send request, so that this has a more generic name, because we will also tweak the logic in there to be more generic. This custom hook should not just be dealing with fetching data. It should also not just be dealing with fetching tasks specifically, because otherwise this hook would not be very reusable. It would be basically limited to one operation, fetching tasks. And that's not what I want here. Instead, this hook should be able to send any kind of request to any kind of URL and do any kind of data transformation, but it should always manage the same state, loading and error, and execute the same steps in the same order. That's the actual reusage we want here. And to make that hook that flexible, we of course also will need some parameters here. We will need some parameters to configure this hook. And what should be configurable here? Well, I would say the request logic. That needs to be configurable. The URL, but also the method, the body, the headers. This all needs to be flexible. So I do expect a request config parameter here. And this in turn then should be an object, let's say, which contains the URL and any kind of other configuration that might be needed. Now, therefore, here, I will get rid of that URL of that hard-coded string here in use HTTP and instead refer to request_config.url. Since we will be calling that hook, we then have to make sure that we pass in an object which has a URL property which holds the URL. This hook should also be usable for post requests, so therefore fetch should take a second argument here. And then there I pass my object where the method should be set to request_config.method, where the headers should be set to request_config.headers, and where the body should be set to JSON stringify request_config.body, so that we perform the JSON transformation inside of the hook, but the body itself is passed in from outside. And again, this is really just my approach here. You could make this more reusable, you could expect different parameters. That's all up to you. This is just one possible solution. Now this request and how this request is being sent is a bit more configurable. Of course, I want to then check the response like this, and I want to transform the response like this. I am assuming here that we're always working with JSON data, so I will not make this hook super generic to work with any kind of data. I will limit it to JSON data, because everything else would be far beyond the scope of this course. And therefore I will keep these steps here, but the transformation and so on, and what we do with the data in the end, that of course is then again highly specific and not something that should be part of this hook. Instead, I would imagine that we get the data here, and then maybe we execute a function which we get from the component that uses the hook, and pass that data to that function, so that the concrete transformation steps can be defined in the component where this hook is being used. So therefore here, instead of executing this code, I do expect to get another parameter here, and that's the, let's say, apply data function. The name is up to you. And then here, once we got the data, we simply call apply data and pass the data to it. So that in the hook, we just hand the data off to this apply data function, and the function itself and what happens in there is provided by the component that uses the custom hook. So that we have that reusability and that reused logic in the hook, but the specific steps that should be taken with the data in the component that uses the hook. This is a split which makes sense to me. Now, with that, we got the loading and the error state and the send request function in the custom hook, but ultimately these are all things which we will need in the component that uses the hook. that component should then have access to the loading and the error state, and it should have access to the send request function so that it's the component which can trigger send request. Therefore, at the end of the custom hook, not at the end of send request, but at the end of the custom hook function, I want to return something to the component where the custom hook is used. And I mentioned before in this module that your custom hooks, of course, can return anything. Numbers, strings, arrays, objects. And here I will return an object. And there I will add a isLoading property, which points at the isLoading state constant. So this is the property name on the left side. This is the value on the right side. And that is isLoading state, which is managed for the component by this custom hook. And I will also return an object with an error property, which holds the error state, just as the loading state. And then the send request property, which points at send request. So at this function here. And since I'm always using the same property names as variable names on the right side, we can also use a modern JavaScript shortcut here where we write this like that. That's the same result, or that will give us the same result as the code I had a couple of seconds ago. It's just a bit shorter, and it will be transformed to that longer syntax under the hood by JavaScript. So that's a shortcut we can use in modern JavaScript. And with that, we got our custom hook, at least the first version of it. Now let's see how we could use this custom hook. Back in the app component, I now want to use my custom hook. And therefore, first of all, we have to import it. So I import use HTTP from hooks use HTTP. Then we can get rid of the isLoading and the error states, because that's now a state which will be managed by the custom hook. So we can just call use HTTP here. Let me actually call this here after initializing the tasks state. Now, the custom hook needs some arguments, because we expect two parameters here, the request config and a function that is applied to that data, which we get back. So, therefore, we should pass that in. And for the request config, we pass in an object with a URL property, because inside of the custom hook, we are accessing a URL property here. And we then also later access method headers and body. And therefore, for the URL in the app component, I will pass in this string here. Now, in the custom hook, we also then expect a method headers and body. And the thing is that for app.js, I just want to get data. And therefore, I want to send a GET request. I don't need any headers, and I don't need a body. And to be flexible enough and to not force all components to then pass in some dummy data or anything like that, I will go back to the custom hook and tweak this configuration here for the fetch request a bit. And in the case of the method here, check if request config method is set. And only if it is set, I apply it here. And otherwise, I set this to get as a default. For the headers, I will check if headers are provided on the request config. And if they are, I, of course, will apply them. Otherwise, I'll set headers to an empty object. And for the body, I'll check if request config body is set, in which case I will stringify it. So transform it to JSON, I mean. But if we got no body, I'll set this to null here. Now with that, the custom hook should be flexible enough so that use HTTP can just pass in an object that looks like this. Now that's not all though. We also need to provide a second argument, which is that function which receives the data here in the end. So therefore, I will define a function here. We could define it inline in the argument list, but to make it a bit more readable, I will define it here before I call use HTTP. And I will add a function which I'll name transform tasks. Here, I then expect to get my tasks object. And inside of transform tasks, I then want to apply the transformation logic which we had in use HTTP.js before. I deleted it there, but I still have it down here in app.js because I haven't deleted this code yet. So it's in the end this logic, lines 30 to 36 here in my case, which I want to copy and add here into transform tasks. And it's the tasks object through which I want to loop here with a for in loop, and which I use down there. And with that, we transform all the tasks from objects, which we get back from Firebase, into objects that have the structure and format we need for our frontend. And then we set our tasks state, which we can still do since we still have set tasks here, and we set our loaded task like this. And now it's the transform tasks function, a pointer at this function, which we pass as a second argument to use HTTP. And then this function will be called for us by the custom hook whenever we get a response. And this is the best of both worlds. With that, we have the main logic in the custom hook, but the data-specific logic in the component where we need the data. That alone still won't do the trick. Use HTTP does not just require parameters, it also returns something. It returns this object with the loading and error states and a pointer at the send request function, which we ultimately will need to call to trigger that request. So in app.js, I will get back my HTTP data here. You can name this constant however you want. And I will destructure it by pointing at HTTP data. And we can pull out is loading, error, and send request. And of course, we can also do the destructuring right here and save that extra line. Now I will also assign an alias here, which is something we can do in JavaScript, by adding a colon here in this destructuring syntax and giving this a different name. And I will name it fetch tasks. So we're still pointing at the send request function from the custom hook. I'm just renaming it here inside of this component function. And with that, I will delete the old fetch tasks function in the app.js file. I will delete it like this, but I will keep useEffect here where I still call fetch tasks. Now here, however, I should add fetch tasks as a dependency now. We should have done this before, but before it wasn't really an issue because in the old fetch tasks function, I was only calling state updating functions, which are guaranteed by React to never change. And React noticed this and didn't warn me before. But React doesn't know this fetch tasks function, so this send request function at the end. It doesn't know what's going on in there, and therefore we have to add it as a dependency to rerun this effect whenever fetch tasks changes. At the moment, this would be a problem though, and therefore I will delete this dependency. We will re-add it later because this is not a good practice, but we will avoid this dependency for the moment because it would create an infinite loop right now, and we don't want that. And therefore with that, we now restructured the app component. We still get access to the isLoading and error states, which we pass on to tasks, to the tasks component down there. And we still get access to fetch tasks, but the logic for sending that request and handling errors and so on is now part of the custom hook. And therefore, if we save everything now, this should work again. And if I reload, it still loads all the tasks. And if I add a new task, that also still works. So that's now our custom hook being used. It isn't finished yet though, because as I mentioned, for example, here, we're not using it in a best practice way. Let's therefore do that in the next lecture. So we should add fetch tasks as a dependency here to useEffect, because you learned that basically every piece of data or function which is set up inside of a component function which you are using in useEffect should be added as a dependency. The problem with that, and therefore you shouldn't save this file yet, is that this would create an infinite loop. Why? Because we will call fetch tasks here, and this will then go ahead and execute this send request function in the custom hook, and that will then set some states. When the states are set, the component where we use the custom hook will be re-rendered. Because I explained that when you use a custom hook, which uses state, and you use that hook in a component, that component will implicitly use that state set up in a custom hook. So the state configured in the custom hook is attached to the component where you use the custom hook. So if we call set is loading and set error here in the send request function in the custom hook, this will trigger the app component to be re-evaluated because I'm using that custom hook here in that component. Now that, however, will then call the custom hook again when that component is re-evaluated. And when that custom hook is called again, I am indeed recreating the send request function, and I'm returning a new function object, and therefore useEffect will run again. And that happens because, as I explained earlier in the course, in the behind the scenes module, functions are objects in JavaScript, and every time a function is recreated, even if it contains the same logic, it's a brand new object in memory. And therefore useEffect would treat it as a new value, even if it's technically the same function, and it would re-execute it. So, to avoid this, we should go to use HTTP and wrap send request with use callback, which we can do also when we use async await in there. This is no problem. So we import use callback and then wrap this function here with use callback. Now use callback also needs a dependency array though, and this dependency array also should list everything which is being used in here. And in my case, that is, for example, that request config object, but also this apply data function which we're calling. Now, this poses yet another problem though. Since that is the case, we should add request config and apply data as dependencies here. But of course, both, again, are objects. Request config is a standard JavaScript object. Apply data is a function, which you learned also is an object. So back in the app component, where we're passing in this object and this function, we again have to ensure that these objects are not recreated all the time when this function runs again, which they currently would be. So here in app component, we also should import use callback and wrap transform tasks here with use callback, for example, and add our dependency array here. And here we don't have to add anything because in here I'm not using anything external other than set tasks, which is a state updating function. And as explained multiple times in the course, these are guaranteed to never change. And if this is looking cumbersome, yeah, it can be tricky to get into. It might look like a lot of work, but it is something you're getting used to over time, and it is very logical in the end. It is simply related to how JavaScript works after all. Now with that, we're guaranteeing that transform tasks will not change all the time, but this object here will. We are recreating it here all the time whenever the app component is re-evaluated. So to work around that, we could look into use memo or anything like that to ensure that this object doesn't change all the time, or we change our custom hook again. Instead of accepting the request config here in the hook itself, why don't we expect it here in the send request function? After all, that is the function which is being called with that config. So we could expect this request config object not here in use HTTP, but here in send request. So here. Then we don't need to add it as a dependency here, because it's now a parameter of this wrapped function, not an external dependency. And therefore we got rid of this issue, and in app component, all we gotta do is take this object with the URL and remove it here, so that transform tasks is the only function we're passing to use HTTP. And we then go to fetch tasks, where we are sending the request in the end. Keep in mind that fetch tasks is just send requests because of this aliasing here. And we pass our config object here. That's something we could do. And of course, we could do something similar with the data transformation function. If using use callback here in app component is too cumbersome for you, if you don't like this approach, we can get rid of that and instead just pass transform tasks as a second argument to fetch tasks here and not to use HTTP, so that we call use HTTP without any arguments. And we actually create transform tasks. Whoops, get rid of the dependencies here. We create transform tasks like this inside of the effect. Then this also is no external dependency in the effect. And now we make sure that use HTTP, our custom hook, can be called without any dependencies or without any parameters, because we're passing the request-specific configuration and the data transformation that should be applied after the request was sent directly to the request. And I showed both alternatives because both would be viable ways of doing it, and I also wanted to show you what the potential downfalls or disadvantages of the other approach are. Now, of course, we need to go to use HTTP and not expect apply data here as a parameter of the custom hook, but instead here for send request. And with that, of course, use callback here in our custom hook has no dependencies anymore because all the data it's operating on is received as parameters in the wrapped functions. We got no external dependencies here. And with all of that, if we go back to app.js, we now have code that should run without an infinite loop and without any issues. If we now go back and reload, the tasks are still being fetched. And again, I'm fully aware of the fact that this can be confusing. I hope I could still explain why the different steps were needed. Of course, I could have shown you that final solution right from the start, but it is super important to understand that there are different ways of achieving this, and the other solution wasn't bad or wrong. This is just a solution which minimizes the number of dependencies, makes this a bit easier to manage, but the other solution would have been fine as well. And most importantly, I wanted to make it clear why we derived this solution now and why I'm going with this solution now. With all of that though, the hook is looking good and app.js works. But of course, the main reason for adding the hook in the first place was to reuse logic across components. And here in the app component, we're fine now, but we still got our new task component, where we also are sending a request. So let's use our custom hook there as a next step. So here in new task, I also want to use my custom hook. And therefore, first of all, we should import use HTTP from hooks use HTTP. Then we can call use HTTP, and we no longer need to pass in any parameters because of the refactoring work we did in the last lecture. Now we still get back an object though, which we can destructure, where we get access to isLoading, to the error, and to send request. And here I will rename send request to send task request. But that, of course, is up to you. We can get rid of the two states here now and of the use state import, therefore, because we're using our custom hook for this now. Now, in the enter task handler, we in the end want to call send task request now. We want to call that here because we want to send that request whenever enter task handler is triggered, which happens when that form was submitted in the end. Therefore, we will soon delete all that code, but before we do that, we need to ensure that we pass the proper configuration and data handling function to send request. And for this, let's start with the config object. I pass in a new object where the URL is set to this URL. And here now, since I want to set a post request, I'll also set the method to post. And I'll set the headers here to the headers object, which I got down there, like this. And I will, of course, also add a body, however, not as JSON, because we're doing that JSON transformation inside of the custom hook here. But instead, I will therefore just send in this object here, which I previously changed to JSON in the new task component. So that's my request config object now. The second argument is a function which takes the response data and does something with it. And the something I want to do with it is in the end this down here. I want to extract the generated ID, which Firebase gives me automatically. I want to create a task object which incorporates that ID, and I then want to call props on add task. So we could either create this function on the fly here, or we create it in advance, like this here, the create task function, let's say. And here I get my data, my task data as an argument. And then we grab this logic from down there, this logic, copy that, and add this here in create task. And data is now renamed to task data like this. And we now use create task to pass this as a second argument here to send task request. We don't need to work with use callback or anything like this here, because we are only calling send task request in the enter task handler, not inside of use effect or anything like that. Therefore, here we won't have the problem of an infinite loop, because this request will not be sent whenever the component is re-evaluated, but only when this function runs, which happens when the form is submitted. That was different in the app component. There we sent the request inside of use effect, and therefore we had the danger of sending the request too often. In new task, we should be fine now. And therefore we can grab this old code here and get rid of all of that, so that inside of the enter task handler, I'm now only calling send task request, and we're configuring it like this. Now in my create task function, I'm missing the task text though. That's a problem. I'm missing the text which was, passed from the form to that HTTP request. We do have that text available here inside of enter task handler. To make it available inside of this create task function, which we pass to send task request, we got two main options. We could either grab this function and define it here inside of enter task handler to have a nested function inside of a nested function inside of the component function. And that would work. Due to how JavaScript scoping works, we now do have access to the entered task text. Or alternatively, we leave it like this to avoid this deep nesting, and we instead expect to get the task text as an argument here, as a parameter in create task text. And therefore we want two parameters here, when actually our custom hook, which is calling create task in the end, only passes in one parameter. It only passes in data. To work around that, we could use the bind method in JavaScript. We could call bind here on create task when we pass it to send task request, and the bind method allows us to pre-configure a function. It does not execute the function right away. Instead, it's a default JavaScript method, which you can use on any function object to pre-configure that function. The first argument you pass to bind then allows you to set the this keyword in the to be executed function, which does not matter to us here, hence we can set this to null. But the second argument you pass to bind will then be the first argument received by that to be called function. So if we want to pass in the task text here, we can set this to task text here, because that will then refer to the task text we're getting from the form submission. Now, the other argument, task data, will still be received here because this is our pre-configuration. Any other arguments which might be passed by the place where the function is then actually being called, which happens in use HTTP, will then simply be appended to the end of the parameter list. So the data, which we pass here as the only argument to apply data in the custom hook, will be appended as a second argument on create task because of us calling bind here. So when it's being called, this receives all the data which is needed. And this is all just regular JavaScript. This has nothing to do with React or with hooks or anything like that. That's just regular JavaScript. You can learn more about the bind method and about pre-configuring functions with a resource which you find attached to this lecture. And therefore now, if I save this, we can reload and still load all tasks. But if I now send another task, if I click add task, we see sending here, and then we see, does this work? So if I reload, it's also still there. We can also see all that data on Firebase. Now if I open the console, I also got no errors there. And if we go to the network tab, we also see that indeed we are not sending an infinite amount of requests or anything like that. Instead, if I clear this and I test this, we are in the end just sending one request. It looks like two, but this is just a side request which is sent along the way. And therefore, this is all looking good. And that is how we can build a custom hook for sending HTTP requests. It definitely had its tricky parts, but with it, we now have this custom hook which outsources or which holds a lot of the duplicate logic, especially all that stateful logic, and we can use it in different components to send different kinds of requests and do different kinds of things with the response data and still utilize this shared loading and error state and this shared logic.